Hey guys, so this was Say It With Symbols 3.2 on more linear equations, and the context of this problem was that we were comparing the costs of two companies, Cover and Surround It and Tile and Beyond, that are companies that advertise for tiling the borders around pools. So we looked at the two advertisements and what their offers were to create equations. So for Cover and Surround It, our equation was C of C, so that's to distinguish that we're talking about the cost of Cover and Surround It, was equal to 500 plus 5n. So this 500 came from our design and delivery fee, which was a one-time flat fee. We didn't have to pay it multiple times, we just had to pay it once. And our 5n was to show that every single tile we purchase was going to be $5, so $5 per tile. And our equation for Tile and Beyond, so the cost of Tile and Beyond, so C of T, is equal to 620. Again, you see our flat fee, this was our design and delivery fee, plus 3n. So for Tile and Beyond, it was $3 per tile. And we talked about first, how could we, without graphing or making a table, figure out how many tiles we would need to purchase at both places for the costs to be the exact same. And so someone in class suggested that we set the two equations equal to one another. So my first equation was 500 plus 5n, and we want to set that equal to 620 plus 3n. And this makes sense because we're trying to figure out when their costs, so C, are the exact same. So if I know 500 plus 5n is my cost for my first company, and 620 plus 3n is my cost for my second company, then I can set them equal to one another to figure out when their costs are the same, since equal means the same. So we remember from solving an equation, we want to get our variables on one side and our numbers on the other. So first we started off by subtracting 3n here to cancel that out, because we wanted to move it to the left side of the equal sign. So we did the exact same on the left side, because whatever I do to one side, I have to do to the other. So that gives me 500 plus, and then 5n minus 3n is 2n, is equal to 620. So now I got all of my variables on this left side, my 2n now, and I want to move the numbers to the other side, my constants. So I see that this side with the variable has a 500, and I want to move it to the other side. So I have to cancel it out from this side first, which means I'll subtract 500 to cancel that out. And whatever I do to one side, I have to do to the other. So now I have 2n is equal to 120. So I have my variables on one side, my numbers on the other, but I want to figure out what not 2n is, but what 1n is. So I know that 2n means 2 multiplied by n, and so to cancel that out, I need to subtract, or excuse me, do the opposite of multiplication, which is division. So I'll need to divide both sides by 2. And when I do that, that cancels out my coefficient, because 2 divided by 2 is 1. And I end up with n is equal to 60. So I know 60 tiles are what I'll need to purchase for the cost to be the same. So the other conversation that we have is, now we know how many tiles there are when the cost is the same, but how do we prove that that answer is correct? And so we talked about how we can plug that answer back into our original equations in order to figure out what the costs are and to make sure that the costs are in fact the same. So our first equation was that the cost of cover and surround it was equal to 500 plus 5 times our number of tiles, which we just found out was 60. So I'll say times 60. And so when I calculate that, 500 plus 5 times 60, I get the cost for cover and surround it, if I were to purchase 60 tiles, would be $800. So when I use my other equation for Tile and Beyond, I want to make sure that when I plug in 60 for my number of tiles, I'm getting the exact same amount, and then I know I've done this correctly. So my equation was the cost of Tile and Beyond was equal to 620 plus 3 times our number of tiles, which again we said was 60. So when I plug that in and I calculate that, I get that the cost for me to purchase 60 tiles at Tile and Beyond would also be $800. So we can see that the costs are the exact same when I have the same number of tiles, 60 tiles. So we know that we've done it correctly, because that was our whole goal, to figure out how many tiles, so 60, when the costs will be the exact same. And then we actually proved this 2 different ways, by making a table and a graph. So I have here the table for cover and surround it, and our table for Tile and Beyond, where we actually used our equations and plugged in different values for the number of tiles to figure out what the cost would be. And you can see that we see both going up at a steady cost, but we see right here at 60 tiles, cover and surround it costs $800, and at 60 tiles, so does Tile and Beyond. So we can see in our table when the number of tiles and the costs will be the exact same. And we can also see in our graph when they'll be the exact same as well. So I see my first line here, the one that just has the points to represent each value, is for cover and surround it. And I can see how that is going up steadily. And I can also see that the cost at cover and surround it is cheaper at this point until I reach this point right here. And then I see my other line, the one that has my X's to represent my points for Tile and Beyond. It actually is more expensive to start out until we reach the point that the 2 costs are the same for the same number of tiles. So when I have 60 tiles and my cost is $800, I can see that my 2 lines crossed, because that's when both values, my number of tiles, my independent variable, and my cost, my dependent variable, are the exact same. And then we can see that they switch places. So now we can make decisions about which company would be the best for us to choose. If we wanted tiles below 60, so we'd probably want to choose cover and surround it. But if we wanted to purchase more than 60 tiles, we're definitely going to want to choose Tile and Beyond, because we see that the cost is now cheaper as we continue on.